What's up guys, welcome to tutorial 22 in our Python language basics course. Here we're now going to expand upon our basic functions by introducing parameters and return values and seeing how to do that in code. We're going to start by adding parameters into a function and learning how to use them. And then adding return statements and learning how to use those to output values. And then finally passing in parameters and returning values when calling upon our functions. So we're going to, I think, expand upon that simple move example that we created previously. The function's okay, but there's definitely some improvements that we need before it would be game ready. So let's head on over to Google Colab. Alright, so we finished last time in section 21 by creating that simple move function that's just moving us forwards by 1. Now there's a couple of glaring flaws here. The first is that we can only ever move forwards by 1. So that means A, there's no backwards movement, and B, what if we need to step forwards multiple steps at one time? Well, we can do this, I suppose, and that works for small steps, but it's really not very efficient because we're doing in 4 lines what should only take 1 line of code. And also, what if we need to move forwards like 20 steps, or for whatever reason, 100 steps? Then we would have to do this 20 or 100 times, and that's just terrible code practice. Okay. Also, realistically, within a game, there are kind of the boundaries of the world. You cannot go beyond those boundaries. So for a simple left-right platformer game, you can't go past the start position and you can't go past the end position. So every time we move, we should probably be checking to see that we're not kind of going out of bounds. Okay? So what we'll do here is first start by allowing the user to specify by how much we're moving, and then we'll work on the kind of bounds checking. So let's start by creating a new cell. Okay. I'm just going to zoom in for you guys there. This is section 22. And we're basically just going to start by copying this stuff over. Okay. So once again, we're starting with an x position of 0. We have a move function, but instead of increasing it by 1, we want to specify by how much we want to increase. So for that, we're going to use a parameter. And this will act as input into our function. So we'll just call this something like by amount. A lot of languages require you to set a type, say integer. Not really the case with Python. We don't care because types are flexible anyway. We just need to specify that there will be a parameter called by amount that we can use in our function. So in our function body now, we're just going to replace that 1 with by amount, and we're good to go. However, now when we call upon this function, we need to pass in that value. So let's say we want to move by 1, just like before, that's fine. We can do a move of 1, and we can print that out. So let's print out our final x position. We'll give this a run, and we get 1. What if we wanted to do the same thing here? We want to move by 4. Well, now we can move by 4, and we get the same result. So 1 function call versus 4 function calls. This is so much more efficient than doing this, and you'll see an enormous increase in efficiency when you're trying to do this, let's say 100 times. The other thing that we can do here is if we don't always pass in a value, we don't necessarily know by how much we're moving, but we need there to be a value, we can use a default value. So for that, I can say by amount is equal to 1. That way we're at least moving forwards by 1. Okay, and I can completely omit this. So if I go to run this, I get 1. So this is called a default value here, because we're saying that if we don't have a specific value assigned to by amount, we'll just default it to be equal to 1. So when we call upon a function like this with no parameters, but it has parameters here, it will take on the default value. If we didn't do this, by the way, and we tried to run this, it's going to give us an error saying that we need some value fed in. Okay, so that's why doing this kind of says that if we don't pass in a value, we'll just default it to 1. If we don't want to use 1, we can definitely specify a different value instead, okay, and that's totally legitimate. All right, so if you know you will always pass in a value, you don't need to worry about the default parameter values, that's fine. If you're not sure about whether or not you will always pass in a value, probably best to use some kind of default value here. Alright, so that is a simple improvement. Now we can even go backwards. We could say -5 to decrease our position, and so on and so forth. Now the second issue is the problem with going out of bounds. So we want to make sure basically that we can't go too far to the right or too far to the left because we're not worrying about Z or Y positions. So for this, we're going to kind of have our move 3.0. So I'm just going to add in a new cell, actually. Probably best that we start there. Again, just going to copy this over. All right. So essentially what we want to do is we want to be able to check to make sure that we're not going too far to the left or to the right. If we are, then we're only going to go as far as the start or end positions. So I think probably the step one will be to create some variables to represent those. We'll the start position of 0 and end position of maybe 10. Okay. And essentially we'll just make sure that we're not going less than 0 and not going greater than 10. Also, just the way that this should be structured to kind of be better code practice is that we're actually not going to create this variable, or we can create this variable now, but we are not going to call upon it from a global perspective. We're actually going to pass in the x position when we call upon the function. So we're going to move by an amount. We're going to have a specific x position passed in. Okay, and that means that we no longer need the global variable, because we're essentially saying that we will always pass in some x position, and we're increasing that x position by this specific amount. Okay, so that's great, but again, there's still no bounds checking. And also, this is now no longer going to affect this x position variable. So what we want to do is output the new x position. So we're going to return our x position, like so. Okay, so now when we call upon this, move, let's say by amount, we want to move by 5. We're going to pass in our current x position, okay, and then we're going to output a value. So this is actually outputting something. So we can say something like result is equal to this. If we want to print result, actually, you know what, result doesn't really make much sense. Let's do final x position. Okay, and then we can go ahead and run that. Now, this is actually giving us an error, just because we have a default value and Python is weirdly specific about the order of things. So actually, let's do this. We'll do x position first and then by amount equal to 1. So if you are adding default values, you have to have your default value parameters on the far right side of things and your non-default on the far left. Okay, so there we go. We get 5 printed out. Okay, so we start at 0. That's whatever value we're passing in. Oh, actually, these should now be switched. So this is going to be x position and 5, like so. Even though the result should be the same. Okay. So now what we're doing, moving with x position and 5, we're just getting whatever value here. We're passing that in. We're assigning the value of 5 to by amount because we're explicitly assigning a value. We're overriding this default value. We're taking 0 rather. We're adding 5 to it, and then we're outputting it. So we're outputting the new x position. When we call upon the function, we pass in those values and we retrieve the return value, store it in final x position, and then we're printing that out. In fact, we could short form this just because we're only printing, really, to doing something like this. Okay, we don't even need to create the extra variable. This function is going to output a value anyway, so we can absolutely do that. We're just going to basically use the result of the function return. Now, it should be noted that this return will break out of the function immediately. It doesn't matter what other code is under here. Okay, obviously it's not real code, but if there was any code under here, it wouldn't be executed. And that's because as soon as a function hits a return value, it exits. We could just do something like this, and that would cause it to exit as well. All right. In this case, we actually do want to output something. Now, this means that you can be clever with your conditionals to make sure that under some conditions, it exits prematurely, and under other conditions, it doesn't. Okay, so this is a bit like using break statements in while loops like above. So we can use a break statement here to exit out prematurely. That's basically what a return statement is doing as well. In our particular case, what we want to do is make sure that we're only returning we're returning the correct x position. That means that we can't return a value that's negative or greater than 10. So rather than just returning the x position, what we're going to do is do a bit of checking. We want to say if x, we don't need the brackets, if x position is less than 0, okay, less than our start position, we can, you know what, let's be better. We can have these as global variables. So we'll do global start position and end position. And we're going to say if the x position is less than our start position, okay, then we're just going to return the start position. Okay, this makes sense. we don't want to go less than 0, so we're just going to return 0. Okay. Then we'll say elif x position is greater than our n position. So if we're more than 10, we're going to just return the n position. So again, we cannot go below 0 or above 10. Okay, and then otherwise we're just going to return x position. Now at this point you might look at this and say, where's the else? Why are we not doing else return n? Okay, so that's fine. If you want to do else, there's absolutely nothing wrong with that. The reason I do this is because I actually don't need the else. The reason being, if any of these tests pass, we're going to hit that return statement and we're going to break out immediately. We're not going to do any of the other logic or anything like that. So if this was the case, we hit this and we ignore all of this code. We only hit this code if the above tests fail, so essentially an else case anyway. All right? So that's just kind of why I'm doing that. Okay, so let's go ahead and run this. Again, we get 5. That was fine. There was no problems there because we're starting at 0. We're only going to 5. Let's say we start at 0 and we're trying to go to 15. Okay, in that case, we get 10 because we cannot go up to 15. As soon as we go above 10, we stop at 10. How about if I'm going to negative 15? Okay, in that case, 0. Again, makes sense. We don't want to go below 0, so we just want to stop there. What we could do here, essentially, is say something like xpos is now equal to move of this. Okay, and then we can print out x position. This would probably be a much better way of keeping track of things. All right, so that is pretty much it. I know we did cover a whole lot in this tutorial, but hopefully I'm sure you guys are super smart and can keep up with this no problem. As per usual, practice is the best thing that you can do. If you're unsure about any of these kind of concepts, then go back and practice them. So if you're kind of struggling here, then definitely try to break things down piece by piece. So try adding just some parameters, and then try adding just some return values. Okay, and then you can kind of combine the two. Remember, parameters can have default values, which only take on this value if we don't pass in an explicit value when calling upon the function. If there are parameters, we have to pass in a value for each of them. We're not restricted to types. You can actually pass in a whole list or a dictionary or a tuple, just like you can output an entire list or dictionary or tuple. You don't have to just output or input one single value at a time. Let's see what else. We can add logic. Just make sure that your function will return at the appropriate times. As soon as it hits a return statement, it will break out of the function. If you're returning a specific value, it will output that specific value. Okay, so you can kind of combine these with some control flow and some logic to make for some very interesting functions. You can also add loops. You can call other functions within functions, and so on and so forth. There's lots of flexibility within Python. Okay, so that's it for now. When we come back, we're going to be actually exploring a whole new topic that will be the last one of our language basics. Do make sure that you are comfortable with functions. We're going to be using functions a lot more in the next sections. So again, make sure you're totally okay with that and with everything else that we've covered moving forwards, because this last topic will be kind of a culmination of everything that we have studied so far. Okay, so stay tuned for that. Thanks for watching. See you guys in the next one.